Hello everyone. So yesterday in this runtime generated terrain system, we worked on how to add multiple foliage types into the system, so that as you can see here in the generated world, you have multiple foliage types, and for each foliage type we defined rules such as the range, height, the elevation range that they can draw, and how far they spread, the clustering, all those parameters. Now we want to work on how to replace the instances of each foliage tile when we move away from the initially generated tiles. So we already worked on this for one type of foliage, but now that we have multiple foliage types, that system is broken. So what I'm saying is, as we go further away, in order to maintain an infinite landscape, we add landscape tiles in front of us, and as we add them, the tiles that are further away from the player are deleted. So here you see now some tiles are being added, and now in the distance you can see over here some of the trees are hanging in the air without a ground. So that's what we want to fix today. So as I said previously, we already worked on this with one foliage system. Now that we have multiple foliage types, that system is broken. See here, you can see foliage is in the air. So what I want to do is, instead of adding new instances, at the moment what happens is new instances are added, but the previous instances are still there. So we need to avoid that. Okay, let's fix that issue today. So this is somewhat like the object pool pattern. That means instead of creating and destroying objects, we just reuse objects that we have already instantiated for new purposes. In this case, instead of creating new foliage instances, we relocate the instances that are further away from us in the landscape tiles that we need to keep visible, that are closer to the player. Right, so before we get started, as always, I'd like to remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel. Once you become a member of the Patreon page, you can download anything without a limit. So feel free to check it out. I'll leave the link in the description below, and that would greatly help me to continue what I do in my channel. And back to the tutorial. Let's open the BP World blueprint. So here under foliage we had replaceable foliage instances. This array used to hold the indexes of foliage instances, or actually this foliage is an instance distract mesh component. So this replaceable foliage instances array used to hold indexes of this mesh instances that we can relocate for different tiles, from the tiles that we have already deleted from the world. Okay, so how do we repurpose this for multiple foliage types? So here, this remove foliage tile, I call this when we remove a landscape tile. So if you right click and find references, you don't see any references here because this function is called from C++. So let me open the Visual Studio project and show you, if you don't remember, show you where do I call it. So this is the function definition, remove foliage tile, and I have marked it as blueprint implementable event. So that's why we can implement it in blueprint level. The reason that I defined it here and implemented it in the blueprint level is because initially, as for prototyping purposes, I wanted to keep this in blueprint level, so later on if required we can move this into C++ level if we faced with any performance issues, so if we have to do that. So right, and if I right click, find our references. Oh, why it's not loading? Okay, anyway, I remember where I call it. Remove foliage. Yeah, here. In this draw tile function, we call remove foliage tile with the index of the terrain mesh that we are going to remove. So okay, now here, as you remember, all we do is get in for one type of foliage the replaceable instances. So instead of this, now we need a set of arrays. So ideally we have this foliage components array, which I keep references to created for instant static mesh components. So we can so the index of the relevant foliage relevant instance static mesh component would be similar to the index of relevant foliage type in the first array. So we need an array of integers which holds replaceable instance indices that is accessible by each foliage type or each foliage component. But how can we do that? Perhaps we can, let's create a new structure and see if we can do it. Structs. The print structure S foliage instances. Okay, now as I said, we need an array of integers. I'll call it instances. Oh, can't I make it capital? Yeah, we can't directly. Okay, now it works. Alright, now here I'll add replaceable foliage. I'll call it pool because I have used the instances here. Oh, okay, now I'll make it from the type of S foliage instances and then turn this into a hold on, maybe we should make it a map. So the initial one would be one of these. I should put this also under foliage. Foliage types. Here foliage type instance static mesh. Okay, so this one foliage type instanced static mesh. Okay, alright, and then turn this into a map. Other type is S foliage instances. Alright, maybe it would be easy if I use as the key, if I use this foliage components. Instance static mesh component. Yeah, Yeah, that should be better. Alright, now, so when we call this remove foliage tile, so we generate this box, and here what we do is we get, so let me this is box min and box max. Right, now let me remove this part. Now what I have to do is we have these foliage components. From this we can get keys. Wait, no. Yeah, right. We have foliage components and we can run a for each loop. Right? Now, for each foliage type, we can run get instances overlapping box. So box is defined here. Now we do get a set of integers, an array of integers which are within this box. Alright, now from this replaceable foliage pool, we have to find if there is an array which holds instance indexes for this given foliage component. If yes, we can break it and access it and append this given array. Right? If not, we can just add. Okay, now I'll get a reference here. Add key is, let me make this a little bit cleaner. This is the key, and instances is this. This is if it's false, and once we run through this for each loop, this function is done. For now I don't really have a purpose for this true false. I don't use it anywhere. Yeah, but here I'll make it true because we actually calculating this whenever I needed it in future. Okay, now this is where we add to this replaceable foliage instances. Now we used to access this replaceable foliage instances and update the instance transform if we have any. So this is the previous add foliage instances. Our new one, this add relevant foliage instances. Here only we have add foliage instance, add instance function only. So now here what we can do is same as before. Here we get foliage instance static mesh component. From this replaceable pool we can find if we have anything that we can use. So here, if it is true, branch, and also let me split this. This has to be true. So yeah, if it is false, we have no option but to add a new instance. If it is true, then first we have to check if we have any instances here. So if the length is larger than 0, that means we do have valid instances that we can replace. If not, again, that means we have to add a new instance. If this is true, we can use this update option. Update instance transform. Now, as the instance index, let me get the first one. That's the instance index, and the transform would be just like here. And scale would be just like here. And rotation is same as before, right? And after we do that, we need to remove this element. Remove index 0. So that that index would be removed from the pool that is available for relocating. Alright, I think that's all I have to do. Let's see, hope it will not crash. I have to move to further location to test this. Where? Let me eject and go to top. If I enable wireframe, so this red marks are trees, and player is here. So if I move player here, okay, new tile added, but I don't see any relocation happening here. So the system we wrote is not working. Oh well, this has to mark as world space, and also I remember I had to add some mark as dirty. Where was it? Here. I made the render state dirty for this foliage component. So I guess I had to, now I have multiple foliage components, I have to make it so for all foliage instances. So I'll collapse this to a function, refresh foliage. Right, now instead of using this foliage only, we have multiple, which I hold in here. For each loop, I have to do the same. Okay, save. Now let's test. Let's wait until all the tiles are generated. Here is the character. No. Okay, if I move here, none of the tiles are removed yet. No, still not working. But I can see only one instance is here. Okay, so then the other possibility is here. Let me make this public. No, visible. Okay, one other possibility is when we add relevant foliage instances and when we remove this, so this is not updated in this structure. What can we do here? Okay, let's try one more thing. Get a bit of space and then let's promote this to a local variable. Let's call it replaceable for and then use this now. Okay, then after making the update, we can again add this like this replaceable foliage pool, add. This is the key, so this should replace the existing array. Alright, I have made this render state also dirty, just in case it matters. I'll wait until the generation completes. Okay. Oh. Right. See, it's working now. Nice. And now let's see if we don't have to make this dirty, because it says if you update in many instances, you should only set this to true for the last instant. So we are already marking it as dirty outside, so right, let's test it again. Oh, it doesn't update. It doesn't remove the tiles if I move too quickly. Let's give it a second. Here is the character. Okay, yeah, it's okay. Awesome. So we are underground. Okay, so yeah, everything is working as intended. Let's look at the system in real time and also stat unit graph. Still tiles are generated, so that's why we see these spikes for each tile added, but it's that amount is reasonable. It doesn't make a huge impact on the frame rate. Let's see when the tiles are replaced. Okay, tiles added, and no more trees without landscape in the distance. Cool. So yeah, the system is now fully restored to use foliage pooling. And actually that's all I wanted to do for today. So I want to come up with a system, to a separate system perhaps, to add grass to the landscape, because I'm not sure if I do the grass also using the same method as I do here, it would require a huge amount of line traces, and if I generate grass for whole tiles, all the tiles that I generate, I'm not sure that's the best way to go about it, but still I'm thinking what to do about that. So yeah, I want to cover that, and also I want to finally integrate my spaceship into this generated world. And yeah, I remember someone commented in the videos that how to harvest these trees or rocks or whatever that you place using this system. I would cover that also eventually. So yeah, thanks for watching. Updated project files will be available here for the download in Patreon page. Link would be in the description below, and see you in another episode. Goodbye.